Hello, everyone. I see some great people in the chat. There you go. All right. Hey, how you doing, my friend? Hey, Gustavo, how are you? I see Rieger there. I see Gustavo. I see Diego, Evan. All right. Wait for, of course, a few more people to come on in. Hello, 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 hello. Yes. We're in great shape today, so all right. Yes. More things. I am great, my friend. Very good. I'm doing really, really well. Having a grand old time. There you go. Hopefully everybody's doing pretty good. Gotta stretch here a bit. All right. Whew. We're obviously gonna wait for a few more minutes here. It's not even 5 o'clock, but wait maybe a couple more minutes after that, and then we'll go ahead and get started here. We have a very good likelihood, by the way. Well, I should say very good likelihood. I said for a certainty that we are going to finish chapter 5 here today. So I'll be talking about the first test there and what the story is behind that. So. How'd that happen? Oh well. Okay. I don't even know how that happens. Oh well. Hopefully you're all ready for today, because I am definitely ready for today. Today was a little crazy to start, but ended pretty good. So how many points is the test? The test is 100 points. Simple, simple. So it's gonna be like right there, 100 points. There you go. Like I swear, it's not gonna be anything grandiose. So. Actually, let me ask you guys a question here really quick. Have most of you tried out the homework there? I just want to know if most of you have, tried the homework in some capacity. I'm doing great, Diego. I hope you're well. I'm doing really good, my man. Because if you have tried the homework there, um, I'm just kind of curious how you guys found that. You know, that's fine. That's fine. Homework won't be due until when the test is due anyway. But really, the question I guess I'm trying to ask is that how do you feel about the homework there? I know people have issues with the online homework and stuff, but is it taking you a while, a long time to do each question, or have you been able to kind of go through it at a semi okay pace or brisk pace? Yeah. So I just want to hear your thoughts about that. So that just may affect what on maybe a couple aspects of the test that I may want to kind of. Some have a lot of questions. That's true. Here's a question for you, Diego. What are too many questions in your opinion? I want to know what too many questions mean. Everybody has kind of a different way of thinking what too many questions actually mean. So I want to be sure that at least I understand your perspectives. Oh, okay. So you're talking about a question with multiple parts. Okay. Yeah, you have to lower. Yes, this is true. This is true, Ivan. You have to put it in lowest terms. It will have the expectation for that. Although I could say 12 over 16 is correct, you still need to divide by 4 to get 3 over 4. So, yeah, it will be. I would have that expectation too, giving you a paper based test. So, do understand that that will certainly be an expectation for the exam. Actually, I probably should talk about that and then maybe do the next couple sections. Well, you know what? I'll wait. Just thinking if I should talk about the test first or just finish these sections and then talk about the test. So we'll should probably do the sections first and then. Yeah, that can be a bit of a struggle there too. That's true, Ivan. I'll give you that. I do have a plan for that though. I do have a plan for that, Ivan. So I agree with that. Sometimes the formatting can certainly get to you, but I do have a plan to kind of combat that a little bit. So um, it's a kind of a workaround, but it'll be kind of the best workaround I can muster here. I think it'll be fair too, a fair workaround. Yeah, that's kind of the thing there. No. Okay, okay. You know what? Since we're on this topic here, let's yeah, okay. So it's about 5 after. So let me go ahead and get started here. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we're going to finish up Chapter 5, and we need to discuss the test. And since we're kind of on the topic of the test, I think I'll discuss that first. I'll probably re-answer these questions here as more people come in. Yeah, let's talk about the test here and a little bit. And then once we're done talking about the test, we'll move on here to finish up these last couple of sections. And then we'll talk about where we're at after that. So the test here, of course, is worth 100 points. Okay, it will cover chapters 1 to 5. All right, so all right. All right, so one thing I do want to make an announcement regarding when the test will be due. The test will be due 1 week from today. So the test will be due on the 23rd, okay, at 11:59 p.m. Okay, so you'll have a week of which to complete the test. Okay. Okay, so now one other thing that I do need to make note of is that all the chapter 1 to 5 homework, okay, all chapter 1 to 5 homework is due at the same day, okay, and time. So all the homework there will be due at the same time, the 23rd at 11:59, and then the homework for chapters 1 to 5 will close at that moment in time. Okay, so as I stated in the syllabus, all the homework is due the day of the corresponding test. So that's basically what will be happening there in that case. Are there any questions about that? Hopefully that'll be pretty clear, at least to what the test, at least some things about the test there. Okay, now Diego asks, so how many questions will the test have? So I kind of thought about it for a little bit, and I haven't quite made up the test yet. I have a good idea about what I want to put on the test, and I'll be posting the test here later today, so you'll definitely see it here later today once I do post it. So since there are 5 chapters, basically what I'm going to do is I'm going to take 10 questions from each chapter. Okay. So I'm going to take 10 questions from each chapter. So we're going to have a total of 50 questions. All right, so there'll be a total of 50 questions for this exam. And the reason why I'm making it 50 questions, and I know it's like saying, wow, that's a lot of questions. I said, okay, that's fair, but there are concessions that I'm making in exchange for having more questions. Number one concession I'm making is that the questions are worth less. So if it's 100 points, then each question will be weighted equally at 2 points apiece. So if it's like saying, I don't know what this question is, I don't know how to do it, okay, fine. That's not a lot of points lost. Okay, that's only 2 points lost. So you're not penalized because of a problem that's like a multi-part problem, as was stated earlier, that gets to be very long. And it's like, okay, no, all right, you're gonna not be harshly penalized for that. I'm not gonna put multi-part problems, by the way, so I don't have an intention of doing that. But you get the general idea about how that's going to work. All right. Now, some questions here may be very basic questions, okay? So like your plus minus times divide questions. However, one thing that will be true about the test is that the majority of the questions will be word problems. So we've focused a lot in this class regarding word problems. So the majority of the questions should be word problems. So I'm probably thinking 35, 40 questions will be word problems of some variety. Okay. Now, of course, I need to be fair in this process here. A lot of word problems is a lot of work. Okay, that's certainly true. Okay, so this is my plan here. My plan is that if you have 50 questions, all right, I'm going to give you a time limit here for this exam, but it's a very doable time limit. So basically, I'm going to give you an 8-hour time limit. All right. So I'm going to give you an 8-hour time limit, and you'll get, for the exam here, you get 2 attempts. Okay. So if you didn't do so hot the first time, you try it the second time, and you get a better score. Great. Okay. So the best score will be recorded. Okay. Now, one more thing that I will definitely do here, and this is certainly by design here, is that there will be a practice test. Okay. So this practice test so I'll have practice test 1 here, will get you comfortable with how the test questions look. So the practice test can be done unlimited times. Okay, you can do those. They'll have you can take those over and over and over again. Okay, if you like, just to kind of get you comfortable with that process. And the questions that you see on there will reflect the questions that you see on the exam, the actual exam. So my suggestion is to do the practice test first, so you get comfortable with the formatting of stuff, because I know that there were some questions in regards to that. And then we're going to go ahead, and then you can go ahead and do the test here when you're good and ready. Are there any questions about that? Got it? Okay. Now I won't record your, yeah. You'll know the score of the, you'll know the score right away. Yes. So it will give you the score and the feedback. And if you're not satisfied with that score, Ivan, you can take it again a second time. Yeah, it'll also mark those that are wrong. Now, one thing that I'm going to allow you to do here as well, and I think that's kind of an extension question off of what I think I probably should say here, Ivan. So I think that's a very fair question here. I'm going to set the test up in a way where basically you don't have to do it in one shot necessarily, but there's a drawback to that. So if you say, you know what, because 50 questions, I'll admit, is a lot. Okay, no question about that. All right, 50 questions is a lot. So you can basically, break things off and then come back to the test, but you cannot answer any questions that you did previously. So it's like saying I want to log out, but because it's quite a long time to do, and I said, okay, that's fair. So you could come back, but you can't re-answer the questions that you already previously answered. So that kind of prevents cheating there. So yeah, so that's the way I've kind of balanced things out. It's about, like I said, you guys will demonstrate to me kind of what you learned there, and you'll see exactly how that goes. Are there any more questions about the test there? I'll be also posting an announcement on Blackboard, so it'll give everybody a reminder once I do post the test. No? Okay. Okay. Like I said, I just want to be very clear about this. All right, so that way it's a fair test and it's not going to be overwhelming. I wanted to make this process as easy as possible. Remember, we're here to learn, so I think the amount of time that I give is fair. I think the amount of questions is fair. Is the second part of the midterm harder than the first 1 to 5 chapters? Well, uh, that varies from person to person. If you're no, that's a fine question, no problem. The later part of the chapters, like chapter 6 and stuff, starts about pre-algebra, algebra, volume, 3D figures, and trigonometry. So that's kind of like the last 5 chapters that we'll be covering there. Now, if you fair enough, man, fair enough. um, so if you find that to be a little bit tougher, yeah. But remember, okay, there is a silver lining to this. Remember, we're only covering the basics here, so we're just skimming the surface here. Okay, we're not getting super in depth on anything here. All right, so we're if you wanted to do in-depth stuff, then that's what you take college algebra or pre-algebra classes for. But we're just looking at surface level stuff here, so it's not intended to like be like super deep into the muck. All right, so um, that's the approach that we're going to be taking. All right, so that will be chapters 6 to 10, and as for the pacing here, I think maybe I should address that. We'll finish up chapter 5 here today. That's all we're going to be doing here today. If you have questions, of course, over anything over chapters 1 to 5, I can certainly do questions in regards to that. And on Monday, we're going to do all of chapter 6. Chapter 6 is not a very large chapter. It's one that you can do in a single day, and I would prefer to focus on chapters 7, 8, 9, and 10. So chapter 7 will take us a couple days talking about algebra, and then we can get on to geometrical figures and a little bit more of the meaty stuff. So that's uh, that's kind of what's on the docket here for the next 2 upcoming classes and so on. So I already have a plan in the back of my mind. Now, let me just say this. Remember, one thing that is important is that the test being due next week only applies to the people who are in the 8-week class. Okay? The people who are in the 16-week class are not under any obligation to do the test. Okay? So I just want to point that out so that way there is no confusion here. If you are registered in the 8-week class, the test is due for you next week. If you are in the 16-week class, the test is not due for you next week. If you are in the 16-week class and thanks, man. If you want to take the test and you're in the 16-week class, it is your prerogative to do so. You may, if you like. I'm not going to stop you from doing so, but those will be your chances if you want. Okay, so it'll be kind of set there. If you'd like to, that's your option, Gustavo. I'm not. It is optional. Yes, if you're in the 16-week class, okay, it is optional for you. It is completely optional for you to take it later. I have a date set aside for the 16-week class because I just want to be able to kind of set it with a 16-week schedule. If you want to do it by, next Wednesday, as Gustavo said, then yeah, you can do that. That's your option. I'm not going to hold you to my later schedule. The later schedule there is to accommodate people in the 16-week course, so they kind of flow with the full 16 weeks. But I know I'm kind of doing it as an 8-week course, so it's totally up to you at the end of the day. I'll be just effectively changing the due date to that time, probably after the 8-week course ends, and then give the 16-week course an opportunity to do the test after that. So that'll be basically what'll happen there. When would I need to know? Like I said, Ivan, you can go ahead and do it if you like. Again, it's an option. I'm not going to force that on you if you're in the 16-week course. So if you don't want to do it and you don't do it by next week, that's not a big deal. Okay. Yeah, I know that's a little confusing, but yeah. You swear tests are made to kill you? Well, I mean, I don't know. I mean, if they did a little more testing, I'm just saying Chernobyl might not have happened. That's a little more testing there. Maybe you did a little more testing. You know, we wouldn't have the space shuttle disaster. Yeah, yeah. You have to test for human error, don't you? Right? That's fair. That's totally fair. Always got to test for human error. That's very important. Human error is the first thing you should test for. You have other people look at your work. Yes, they're testing. They're testing to see if you have the skills that pay the bills, my dude. Oh, just a little error doesn't mean that a dam will break. Or does it? Are there any other questions about the test? If you want to know why you should test, here's a good one here. Here's a good one here. For all those engineers or for all those people in the trades, this is why you do tests, guys. Let's go show a video. Let's show a small video here about the Tacoma Narrows Bridge. This is what happens when you have poor engineering. Okay, this is what happens. You get this. As you can tell, yes. The unfortunately, this is what happens when engineers did not take into account gale force winds. Hey, other bridges were made, and yet they didn't take into account the gale force winds. You got to take more environmental studies and environmental factors. And then the road basically breaks and snaps and falls into the water. Mind you, this is not the worst engineering disaster, but probably the engineering disaster is probably like the Bay Bridge or uh, Embarcadero Highway during the Loma Prieta earthquake of 1989. Those are things were made really poorly. So yeah, you can see that it literally, things that are supposed to hold it together are literally moving back and forth. Imagine if you're writing that though. Jeez Louise. Eventually this will crash to the ground after wobbling a bunch. The road literally splits. This is probably a famous picture you guys seen before. And then total collapse here. Yeah, the result didn't turn out very good. Gotta be careful about that. Alright, this is why we do tests. Yes. The bridge in your brain will fall apart if it does not. I'm just saying. Alright. Now that we've done that, that's great. Alright. Alright. Let's get started with the real material here today. Alright. So today, we're going to do the last couple sections here of sections 5.4 and 5.5. Okay, so last time, in sections 5.2 and 5.3, we specifically went over the US system and the metric system. Okay, so we went over both systems. We talked about it. We did some word problems in association with it. All right, so today in section 5.4, what we are going to be doing is we're going to be covering essentially the conversion between the metric system and the US system. Okay, so there are certain conversions that if you want to convert from our system to the metric system, and likewise, then you have to know what those conversions are. You want to look, I always say the lazy way is the best way, but if you want somebody to do your homework, you better bring out the cash on Venmo. All right? That's how it works. I start at 3 digits and work my way up. Those 3 digits start with 999, and I don't have a decimal in it either. All right, so let's take a look at some very important conversions here, nonetheless. Okay. So here are some very important conversions. Like, for example, this is one that's used pretty much universally. 1 inch is 2.54 centimeters. This is probably, if you're in the trades, this is one of the most important measurements that you have to know. Same thing applies if you talk about millimeters as well. 1 inch should be 25.4 millimeters. Let me go ahead and put that down there on the Word document. So the reason why I actually specifically point that out in this case is I don't care about this. All right. Okay. The reason why I point this out, along with 1 inch being 2.54 centimeters, is because I've seen on certification tests, and I've taken certification tests when I'm working with the manufacturing program, and they'll have this exact question, like how many millimeters in an inch. They have this exact question on there, or how many centimeters in an inch. So that question I know for a fact pops up, and it pops up quite often actually on a lot of those certification tests. All right, so that's not something that you say, oh, well, what's the use? Be like, no, if you're doing a trade, yeah, that definitely does play a factor into helping you pass your cert test. So hence why I wanted to point it out. Okay, let's take a look at some others. For example here, 1 ounce is 28.35 grams. This one here, 1 pound is 0.4536 kilograms, or another approximation that we can kind of use is typically people will do this. They'll, if you go overseas, they'll say, well, I'm 80 kilograms or whatever. I'm definitely not 80 kilograms, by the way. No, sadly. 1 kilogram is approximately 2.2 pounds. So you can kind of figure how that works here. 1 kilogram is 2.2 pounds. So if, say I'm 80 kilograms, you take 80 times 2.2, and you can find that person's approximate weight. Okay, so entirely possible there for conversions if you're doing overseas math in your head, just a little bit. Let's see here. Other ones that are important: square inches to square centimeters, square meters. Okay, so we talk about, say, home sizes. Okay, if you're trying to compare home sizes in, like, say, Japan to home sizes in the U.S., we talk about square footage and they talk about square meters. Okay, so there is a conversion for that as well. All right, and of course, a volume. Since we talk about between gallons and liters, you travel up north, everything's in liters. So 1 gallon is 3.785 liters. Again, the best approximation that people use is about 4 liters. So if you take 4 liters to a gallon, it's not exact, obviously, but at the same time, if you take a look at the prices in Canada, it says, oh, it's $1. Say it's $1 per liter. Well, you can approximate in your head. It's like, okay, it's about $4 a gallon. All right, something to that effect. All right, so is it exactly $4 a gallon? No, but again, you kind of have a guesstimation in your mind about where it's at. So when you actually do that out. Any questions so far about that? Does that equal sign have the same name under the weight section? You mean this wavy one here? If you're talking about that, Ivan? Ah, okay. Um, okay, so that guy there, let me go ahead and showcase that. That's a good question there. I need the math type stuff, though, in order to showcase that. All right, so that there is going to be this. This represents approximately equal. So this represents approximately equal. So it's not exactly equal, it's approximately equal. Okay, so about, all right? So that's what the wavy equal sign represents. So so I could say 1 inch is definitely 2.54 centimeters. It's exactly 2.54 centimeters. 1 kilogram is, I could say approximately, I probably would put this in place of this equal sign here. I would say it's approximately 2.2 pounds. So you can see the difference here. I'm going to go back to the page here. You can see the difference here. This is like, say, 1 gallon is approximately 3.785 liters. It's not exact, but it's about that value. However, if we look here, one teaspoon, excuse me, is exactly 5 milliliters. Okay, because we have a hard equal sign here. So that's the difference between, say, the wavy equal sign and then the just regular equal sign that you see there. No problem. Any other questions before we move on? All right, let's go ahead and move forward here. Let's talk about the key behind this. Okay, so what is the key behind this here? The key here is to know what units you want at the end of the day. All right, know what units you want at the end of the day. That is what you're looking for here. You will, again, this is going to be, hey, we're going to use these conversions as a medium to finally get to the units that we want. All right, so just the same techniques that we employed in the last two sections, we're going to employ here in this section as well. Okay, so if we need to convert, say, inches into millimeters, we have a conversion for that. Okay, if we're going to put one value on the top, one value on the bottom, do some multiplication and stuff. So exactly the same techniques as we talked about the last two sections, and that's pretty much our game plan moving forward. Now, for us to do that, let's go ahead and take a look here at some problems. I'm going to kind of skip these here, and I'm going to do some word problems here. I want to get to word problems right away. so we know what we're working with. Okay. Okay, so let's look at, let me go ahead and make this a bit bigger here. There we go. All right, so let's look at number 6. Okay, so number 6 says, standard American carpeting comes in 12-foot widths, but European carpeting comes in 4-meter widths. What would this European width be in feet and inches, round to the nearest half inch? Okay, so let's answer this question here. This question isn't too hard, but let's answer this question here, at least in this case. What exactly are we trying to convert? And what exactly are we trying to convert? Are we trying to convert like feet to meters or meters to feet? What exactly are we trying to find here? That's what we have to answer here. What are we trying to convert here? Okay, that's correct, Ivan. We want to convert 4 meters to feet, right? So we're going to go from meters to feet. All right, so let's get our little paint tool guy here for our first problem of the day. Let's make this canvas a bit bigger too. Boom. No. Yes, bit bigger. Yes. Haha. All right. And no, that's. Here I thought I was doing good, and I was not. All right. All right. So let's look at 4 meters here. So we're gonna have 4 meters up top here. Put that over 1. Now let's go ahead and take a look here at the conversion between meters to feet. Okay, so let's go back here for just a second. All right, and we'll go back a page. This can be found on page 335. So 335 is where you can find that table in the e-text. So again, just like I said before last class, you're under no obligation to memorize this, okay? You're under no obligation to memorize this at all. Okay, I would like you to use it just like we're using it for this problem, okay? All right, so what conversion should we use here in this case? What conversion should we use here? I want to convert meters to feet. So do we see anything there? Well, let's take a look, right? Do we see anything from feet to meters? Well, the answer is no, but we do have one conversion here that is helpful. Take a look. We have this conversion right here. We have 1 foot equals 30.48 centimeters. So let's think about it this way. Even though we don't have a direct conversion from feet to meters, we do have a direct conversion from feet to centimeters. So let's use centimeters as a medium to get to feet. Okay? So let's go back to our guy here, and we'll come back to this chart here. But how many centimeters are there in a meter? How many centimeters in a meter? That's correct. It is 100. Very nice. So we're going to go ahead and do what we did last time. I'm going to put 1 meter down here, and we'll put 100 centimeters up here. All right. just like so. Okay. Now, as you can see, we have centimeters now. All right, that's what we got. We have centimeters, but we want to get to feet. So we're going to use this conversion that's in our chart, is 1 foot equals 30.48 centimeters. So since we want to cancel out centimeters and leave feet, we're going to put the centimeters here on the bottom. And we see here that centimeters will cancel out. And now we can see what our calculation needs to be in terms of how many feet that's going to be. So we have 4 times 100 on the top, and then 30.48 on the bottom. We're going to use our calculator to find this guy out. And so here we get 13.12. Okay, or if we're rounding the nearest half inch, then 13 inches, thereabouts, the closest one. So, all right. Any questions about that? No? Okay. All right, let's try another one. All right, let's look at another problem here. Okay. All right, here's another one. So let's take a look at this here. All right, let's look at number 14. Number 14, one of my favorite problems in this. So let's look at 14. Culinary arts. Fried crickets served as an appetizer sell for 5,400 Cambodian rials per kilogram. If 4,060 rials are equal to $1, how much will 5 pounds of crickets cost in US dollars? Okay, so we're trying to figure out how much a bag of 5 pounds of fried crickets is going to cost us. I don't know if you've ever eaten fried crickets or grasshoppers before. I don't know. It's up to you. I've eaten grasshoppers before. Those are pretty good. So, certainly not the strangest thing I've ever eaten, but I don't know about you guys, though. All right. So, how are we going to solve this? How are we going to solve for how many pounds, how much money it will cost to, uh, how many reals it will cost for 5 pounds worth of crickets? Yeah, I've actually heard they're really good too. Actually, yeah, definitely. I know some countries they fry some insects like ants and crickets. You know, they kind of fry them together with a little bit of seasoning. They are good. I will say this: they are good for protein. That is absolutely true. When will the test be posted? The test will be posted today, probably later on tonight. I'm going to post more details regarding the test here on Blackboard. So, but it will be due next week at midnight or 11:59 p.m. technically, and the homework is also due at that same time as well. I'll also post a practice test as well for you to work with before you try the test. You'll get 2 attempts and things. Where can I get some fried crickets? That's a great question. That's a great question. Let me look it up here. I'm looking on Google. The first thing I looked up is fried crickets for sale, Chicago. Looks like you could buy them online. All right, so that's fine. Here you go. How about a plate laden with grasshoppers or fried silkworm caterpillars? I see. I've had raw silkworm. Boy, that's pretty it's pretty rough. That's okay, Tracy. It's all good. You came at a very opportune time. I like they all show PetSmart. Mmm. We're talking about fried crickets because it's in the problem. I don't know if you've ever eaten fried bugs before, Tracy. But they are good. Just not raw. Not raw silkworm. That just tasted so chalky, man. Oh. Yeah, it definitely needed to be fried. All right. Let's find out how much 5 pounds of crickets will cost in US dollars. All right. So what do we know that it's served at 5,400 riel Cambodian riels per kilogram. Okay. So the question is that what should we do first with 5 pounds? What should we do first with that? Is it really? I gotta try that. I've had gator before. Gator tastes like chicken. Convert to kilograms. Yes. Okay. So we're going to take 5 pounds and convert it over to kilograms. All right, so let's do that. So we have 5 pounds. Put that over 1. Let's take a look at our conversion chart and see what we need to use to convert it to kilograms. We'll go to the previous page here. Okay, is there anything on our chart here that we can use to convert pounds to kilograms? Okay, and okay, so where do we put the 1 pound and where do we put where should we put the kilograms? Should we put the kilograms on the top or should we put it on the bottom? Pounds on the bottom, okay. All right, that's right. Pounds need to go on the bottom, and you're correct. Kilograms need to go on top. All right, so we're going to eliminate pounds, all right? And so we have kilograms here. Now, let's understand one thing here. That's right. Let's understand one thing here. One thing to understand is that I'm not going to round this answer, okay? I'm just going to take 5 times this 0.4536, okay? And I'm not going to round this answer. So one of the things that's important here in regards to a process is you never round in the middle of the process. So Actually, one of those kind of interesting things. Let me go ahead and put that down here. So never round in the middle of the problem. Only at the end. Okay? So if you ever round in the middle, then that's where things go wrong typically. So always round at the end. That's basically the standard MO that you want to take for all of these problems. All right, so we get here 2.268 kilograms. That's the exact answer here. Okay, now we know how many kilograms 5 pounds is, so now we need to go ahead and figure out how many reals it's going to cost us, Cambodian reals, it's going to cost us to buy these fried crickets. One more page. There we go. All right. So as we can see here, it sells for 5,400 Cambodian reals per kilogram. So what we're going to do here is we're going to multiply by 5,400. This is 5,400 reals per 1 kilogram. So the kilograms will cancel out. This leaves us with the reals that we will pay in local currency, in this case Cambodian currency. Now, it also says what's the conversion from Cambodian reals to dollars, and that says 4,060 reals are equal to $1. So we are actually going to multiply one more time by 4,060 here, reals, and $1. All right, so what we have here as our calculation is 2.268. Times 5,400. And we'll put that over 4060. And then on a calculator, we're going to figure that out. So I'll let you guys do that here. See if you guys get the same answer I do. So if anybody can give me an answer there, that'd be good. It's 4060 on the bottom here. Round it up 1 more cent there, Ivan, because there's a 6 next to the 1. Yeah, so I want to just show off here. Yeah, that's right. So what we get here is 3016, right? But we need to round that up to the nearest cent, so we'll go $3.02 here. So just be a little bit careful about that, guys. It's just like make sure you round. If you're talking money here, yeah, because of this 6, that's why we rounded up to 2. So $3.02 for this 5-pound bag of crickets. Pretty good. It's a pretty good price. Pretty sure nobody's going to complain about spending $3 on crickets. Okay. All right. Let's look at the next one here. Okay. Let's look at the next example here. Okay. Yeah, it's that one. Right. Okay. Yeah, there's a couple more I want to do here. So, all right. Let's take a look at 22. So there's a couple more that I do want to do from this section, and then we'll move forward here with the next one. So it's like I knew there was one more. All right, two more. All right, so let's look at this one here, number 22. Number 22 says, the standard recipe for chocolate chip cookies calls for 12 ounces of chocolate chips to make approximately 60 cookies. An American visiting Europe wants to make 200 cookies for a Christmas party. Because chocolate chips are difficult to find in Europe, he decides to chop up some chocolate bars to replace the chips. How many 100-gram chocolate bars will he need to purchase to make this? Assume that you can't buy a fraction of a bar. All right, so we need to figure out a few things here. He needs to make 200 cookies here, total. But all we know is that 12 ounces of chocolate chips makes approximately 60 cookies. Okay. So, what do you think we should do first here in this problem? What do you think would be a good idea here in this problem to do? What do you think, guys? What should we find first? This one's a little tough, so okay, that's right, Ivan. I need to know how many ounces we need for 200 cookies. We know how many ounces we need for 60 cookies. We don't know how much that is for 200 cookies. Grams to ounces. Now we will get to that point there. So both of those ideas that you pointed out there are very good. Okay. So we're actually going to use both. But the first thing we need to do is figure out how many ounces we're going to need overall for the 200 cookies before we buy the bars. So let's go ahead and do that first, and then I'll take your suggestion there, Gustavo, and we'll convert that to grams afterwards once we figure that out. Okay, so we're going to set up a proportion here, okay? So we know that 12 ounces over some amount of ounces here. We know that 12 ounces magically equals 60 cookies. And then some amount of ounces equal 200 cookies. Okay. Now we're going to cross multiply here. All right. So here we get 60x equals 12 times 200. So you get 60x equals, and if we do this out, this is 2400. All right. Next, we'll divide by 60 on both sides. And so x here finally is equal to 40. All right, so this is 40 ounces to make those 200 cookies. Okay? Does everybody understand how we came up with that number there? Are there questions about that? I hope that's clear there. No questions? Okay. Just want to be sure that that's clear so it makes sense, All right. Let's convert those ounces into grams, okay? So that was suggestion put forward by Gustavo there, so let's do that. So We're going to multiply this 40 ounces. Let's look at our conversion little table here. Okay, so let's go back a couple pages. Maybe 3 pages. All right. So what's our conversion that we're using here in this case? What conversion are we using here? All right, cool. That's exactly right. 1 ounce is equal to approximately equal to 28.35 kilograms. So we're going to go ahead. Yes, sir. So where are we putting? Are we putting ounces on the bottom or are we putting it on the top? We're putting ounces on the top? Are we sure about that? Grams on the top. Okay. That's right. Okay, so again, here's how we don't guess. We want to put ounces on here on the bottom because then we can cancel out the ounces just like those. So then we definitely put the grams on the top as a result. Remember, position basically where the units go is basically what you want to cancel out. It needs to go on the opposite side. So we certainly have that. Let's go ahead and multiply that and see what we get. So what do we get if we multiply that? Let's take a look. Okay, so this is equal to exactly 1134 grams. So this person needs 1134 grams of chocolate. Now what do we do? Let's go back to the problem here. So one more part of the problem here we haven't addressed. So yeah, divide by the weight of the bars, correct. And each bar here weighs, according to the problem, weighs 100 grams. Okay, so because this weighs 100 grams straight up, we're just going to go ahead and divide by that 100. So if you divide that out, that's going to be 11.34. Now, because we're not allowed to buy half a bar or a fraction of a bar, we have to buy the full bar out. So this is going to be equal to 12 bars of chocolate. Okay. So we have to get the extra bar in order to get our required amount. Any questions about that? No? All right. Very good, very good. So hopefully that's not too bad. Okay, let's move on to the last one here in this section. So just one more here that we need to do. Oh yeah, sorry about that. Is this a bit better now? I just moved it to the center. I'll wait and just let me know when you're done there, Gustavo, and then I'll erase it because I don't want to erase it right now. All right. All right, let's go ahead and move on here. Gustavo, are you done? You got it? Okay, cool. Got it. All right, so let's go ahead and move on here. Go ahead and erase this out. Okay, so the last problem we're going to do here is going to require us to do just a conversion here. So, all right. All right. All right, so let's look at 27 here. 27 says the cruising speed of a Boeing 737 is approximately Mach 0.74, meaning 0.74 times the speed of sound. If the speed of sound is cruising if the speed of sound at cruising altitude is approximately 295 meters per second, what is the cruising speed of the 737 in miles per hour? All right. So what we need to do is we need to convert 295 meters per second into miles per hour. Okay. So we're going to do, it's going to be a little bit longer here, but let's look at this one step at a time. Okay. So we're given here the straight up 295, and we're going to go ahead and put in our units here. Meters per second. Bleh. All right. Remember what we want here. We want miles on the top and hours on the bottom. Okay, so we want miles per hour. That's what we're looking for here. Now let's focus on just one of them, because one of them is really easy, and that is converting seconds into hours. That should require very little effort, okay, to do. It's just doing time stuff here. So we're going to put 60 seconds on the top here. Again, 1 minute. And then 60 minutes on the top here. And 1 hour. Again, this cancels out the minutes. This cancels out the seconds. And as you can see here, we have hours. Perfect. Okay? So far, so good. Okay. Now that we've gotten it down with hours here on the bottom, we need to convert meters here into miles. So let's go back to our little table here. Let's see what we're working with. So, see if we have a conversion here from meters into miles. Or if we don't, well, we can find a medium to get there. So that'll be helpful. All right, let me go back here. Okay. So do we have a direct conversion from meters to miles? Do we see a direct conversion from meters to miles? Just a yes or no question here. No, that's right. There's no conversion here directly from meters to miles, but we do have a conversion here from miles to what? Absolutely, that's right. We can use, we can use kilometers, right? We can use 1 mile equals to 1.6093 kilometers. But first, before we can use that, we have to put it into kilometers first, and then we can use the conversion. So we're going to use kilometers as a medium to get to miles. Okay, so we're going to convert meters into kilometers. So how many meters in a kilometer? How many meters in a kilometer? 1,000, that's correct. So we're going to put 1,000 here on the bottom so that the meters cancel out, and 1 kilometer up here at the top. Okay. Now we can go ahead and use that conversion of miles to kilometers, and we can figure out how many miles we're working with. Okay, so we're going to put 1.6093 kilometers and we're going to put 1 mile here on the top. So again, the kilometers here should cancel out. Okay. So here we get, again, let's take a look at what we have here. We have 295. We have times 60 times 60. I'm going to divide that by 1,000 times 1.6093. Yes, we do have to multiply by one more thing here. We're going to multiply this answer by the original problem, and it said there was a factor. What was that? Let's go ahead and take a look at what that factor was. 0.74. So 0.74 was in number 27 here. It says 0.74 times the speed of sound here. So I'm going to multiply that, whatever this answer that you get on the calculator, multiply that by 0.74 at the end, and we're going to arrive at our final result. So let's go ahead and do it out. You guys tell me what you got. Hopefully it matches mine. We'll go up to 2 decimal places for this. Okay, that is correct. All right, 488.34 miles per hour. All right, any questions about that? Sure, we're okay there. Okay. For some reason, there was a problem there. Okay. Alrighty, let's go to the next section here. Okay. All right, let's go to the next section here, which is going to be section 5.5, the last section in chapter 5. So this is talking about direct measurements. Okay, so with direct measurements, we're going to be taking a look at a few tools that talk about direct measurements. Now, I'm not going to go over everything in this section here necessarily, but there are a couple things that I want to talk about. They talk about rulers and how to measure stuff on rulers, okay? And that stuff there is, it's not super exciting. It is what it is. So it's not very interesting. I'm not really going to go over it too much or at all, really. But what I am going to go over are micrometers, okay? So if you're in the trades, all right, micrometers are going to be one of the most important tools that you may use for smaller dimensions. Now let's go ahead, and I want to bring up a small video here about Okay. Let's go ahead and take a look here on how to read a standard micrometer, and we'll take a look on how this works. So let's go ahead and I know this video will be slightly a bit boring, but hey, how's it going, my friend? I hope you're well. We're going to talk about how to read a standard micrometer here. So let's take a look. Right. Gonna need to make adjustments here. You're very wasted. Well, perfect. This is the perfect video for you. Reading micrometers. Yeah. Let's go ahead and give it a go.
Micrometers are used every day by mechanics to measure wear on the parts. Having the ability to read them quickly and accurately is important for the mechanic. There are two types of standard micrometers. The standard micrometer can measure to within 1/1000th of an inch, and the vernier micrometer can measure to within 10/1000th of an inch. Choosing which micrometer depends on the accuracy you desire. For this lesson, we'll focus on the vernier micrometer to make measurements within 1/10,000th of an inch. The major parts of an outside micrometer are anvil, spindle, sleeve, thimble, and ratchet stop. Before using a micrometer, make sure the ends of the measuring surfaces are clean and that the micrometer is properly calibrated. Use a piece of paper or cloth and clean the measuring faces thoroughly. Check the calibration of the micrometer by using the ratchet to close the measuring ends and checking to see if the zero line on the sleeve is lined up with the zero line on the thimble. Use a spanner wrench in the small hole on the sleeve and turn the sleeve until both zeros line up. There are 40 equal lines on the sleeve, and each line represents 25/1000ths of an inch. Every fourth line is a little longer and represents 100/1000ths of an inch. For example, the line marked 1 represents 100/1000ths of an inch, and the line marked 2 represents 200/1000ths of an inch. The beveled edge of the thimble is divided into 25 equal parts, with each part representing 1/1000th of an inch. When the thimble is turned one complete revolution, it advances the spindle in or out 25/1000ths of an inch. To read a vernier micrometer, first add up all the numbers to the left of the thimble. Using this picture as an example, the largest number to the left of the thimble is 1. Write this down as 100/1000ths of an inch. Now count how many 25/1000ths lines there are between the large number 1 and the thimble. As you can see that there are 3 short lines showing. Write this down as 75/1000ths of an inch. The next step is to read the thimble. Look at the thimble and see what number lines up with or are just below the line on the sleeve. This is written as 9/1000ths of an inch. The last step is to read the vernier scale. Find the line on the vernier scale that lines up with the line on the thimble and write down this number. Do not write down the number on the thimble. Add up all the numbers you wrote down and this will tell you what the micrometer reads. In this example, the measurement is 1,844/10,000ths of an inch. In this example, the number 3 is to the left of the beveled edge. This is written as 300/1000ths of an inch. There are 2 quarter lines, and 2 times 25/1000ths equals 50/1000ths of an inch. The thimble line just below the sleeve zero line is 6. One cannot count the number 7 since it has not come around yet. This is written as 6/1000ths of an inch. The 6th line on the vernier scale is lined up with the line on the thimble, and this is written as 6/10,000ths of an inch. The total measurement is 3,566/10,000ths of an inch. In this example, the 4 is to the left of the thimble. The number 5 line is visible, but cannot be counted since the 0 line on the thimble has not...
Alright, I'm going to stop right there for a second. I'm going to go back to this last example. This last example is actually rather good. But I'm going to break it down just a bit further. So So here you have the thimble here. You have the side piece to the to this. So on the sleeve. So thimble in the sleeve here. Now, one thing is important is like, why is this 300 thousandths, as they like to say? Now, I do want to point one thing out here in regards to this particular example. So I'm going to kind of bring this up here using the good old paint tool. Okay, so there are steps to this process here. Okay, so the steps to this process here are not too hard, but again, I just want to show you how to justify where he's coming up with these numbers here. Okay, first and foremost, anything on the sleeve here, okay, anything on the sleeve here represents 100 thousandths. Don't worry, no, you're not disrupting. Okay, trust me. I can show you a video on the Hypnotoad, and I'm sure I'm gonna knock you the hell right out. It's like free LSD for your brain. All right, so each one of these numbers here represents 100 thousandths. But what does 100 thousandths represent on a micrometer? That 100 thousandths is actually 1/10 of an inch. So we call they typically in the trades they call it 100 thousandths, but really in reality you're taking that 3, that last number you see there, and you're actually multiplying it by 0.100. That's what they call 100. That's what they call 100 thousandths. Okay. The reason why they call it thousandths here is because the last it goes out to 4 decimal places basically. So a micrometer with a vernier scale adds in the 4th decimal place. So 4 decimal places with a vernier scale. So that's where he's justifying where you're coming up with 300 thousandths or 3.30 is actually taking that 3 and multiplying it by 0.1000. Okay, so that's like the first step there. The second step, let's go ahead and continue the video here.
Is to the left of the beveled edge. This is written as 300 thousandths of an inch.
Okay, let's stop here for just a moment. At this next step here, we want to see how many lines we see to the right of that first number, that last number that we see here, to the 3. So once we measure the piece and it's nice and firm and secure, we can see that we see 2 lines here next to the 3 appear next to on the sleeve here. So that's as far as it went. Each one of these lines here represents 2,500 or 25,000. So essentially, what does that mean in terms of a calculation? Let's look here. I'm going to take that 2 because I see 2 lines here. Okay. Oops, that means that. I'm going to take that 2. I'm going to multiply it by 0.025. So this is where he's justifying the 0.050 here. In this case, is these 2 lines that you see here on the micrometer. Okay, so I'm just showing you, like, hey, this is where he's getting these calculations from. He doesn't get it out of nowhere. There's a step-by-step process, as he's pointing out here. All right, let's go to the next step here.
There are 2 quarter lines, and 2 times 25 thousandths equals 50 thousandths of an inch. The thimble line just below the...
Okay, now he's looking at the thimble. Now the line, it can't pass that 0 mark as you see there. So if it hasn't, it's past 6, but it hasn't hit 7. Even though it's closer to 7, we're not rounding up. You always round down. So notice here, this side here on the actual thimble. All right. So let's look here. Okay. So on the thimble here is step number 3. That number that's on the thimble that you see here that doesn't go, that can go past a little, but round down. So again, round down. You're going to take that number, in this case 6, and you're going to multiply that by 0.001. Okay, so that's where he's coming up with the 0.006 part here, is he's essentially multiplying it by that factor of 0.001. Okay, now the last step that he's going to show off is that last decimal point, this decimal point here. This can appear on some micrometers, and other micrometers it may not. Some micrometers, if you go to the lab there, some micrometers don't have that last decimal place. Some micrometers do have that last decimal place. So some have vernier scales, some do not have vernier scales. So it's important to know if you see a vernier scale micrometer is more, it has much more precision. It has that last decimal place associated with it. And you can actually, again, figure out what that last decimal place should be. Let's go to the next step here that he mentions, and you'll see how this works.
The sleeve 0 line is 6. One cannot count the number 7 since it has not come around yet. This is written as 6 thousandths of an inch. The 6th line on the vernier scale is
Okay, so let's stop here for just a moment. This is the last part here of reading stuff a micrometer. So you're going to have this vernier scale, and as you see here on the original picture, notice you have these lines 1, 2, 3, 4. This could go all the way up to, as much as you know, this goes all the way up to, let's say, this goes up to 9. And you're actually looking, you don't have like a reference, you kind of have a reference here on the thimble. You look for the line on the right hand side that best matches up with the vernier scale here. So if this line is the best one that matches up, then that's the one you go for. You go for 7. But there's one that's better. In this case, that happened to be 6. Okay, so you have to look at the micrometer here very carefully in order for you to actually measure that out appropriately for the vernier scale. So the vernier scale here, actually it doesn't matter about where 0 is. What it matters is which line on the thimble matches best with which line on the vernier scale, and that's going to be your last decimal point. So essentially what you're doing here is you're taking that 6 there, and then you're going to multiply that by 0.0001, because that reflects that last decimal point, just like so. And so this is going to justify all of his calculations here about where he's coming up with each piece of the puzzle. So he gets 300 thou here, he gets 50 thou here, and here you get, again, 6 thou. And here you get the last decimal point being 6. So putting it together, you basically have each one, you have 0.3566 will be your ultimate measurement at the end of the day. So that's how you actually use a micrometer here. I kind of wish we did this one in person, because I would actually have examples for you and parts for you to go ahead and measure with a micrometer. Sadly, unfortunately, we don't have that option. But yeah, but that's how you can practically use a micrometer there in the shop if necessary. Again, there's the regular micrometer. There's also the depth micrometer that works pretty similarly as well. Any questions about micrometer stuff? I'll play the rest of this video here, but I just wanted to show the basis of his example. No. All right, let me go ahead and play the rest of this video here, and then we'll take a look at his last example, and then see based on his last example here, see if you can put it together now that you have the basis about how to do this. So let's go ahead and show off the last part of the video. Let's see how you guys do.
lined up with the line on the thimble, and this is written as 6 10,000ths of an inch. The total measurement is 3,566 10,000ths of an inch. In this example, the 4 is to the left of the thimble. The number 5 line is visible, but cannot be counted since the 0 line on the thimble has not come around and lined up with the sleeve 0 line. There are 3 quarter lines, and 3 times 25 thousandths equals 75 thousandths of an inch. The thimble line just below the sleeve 0 line is 24 thousandths of an inch. The 4 line on vernier scale is lined up with the line on the thimble and is written as 4 10,000ths of an inch. The total measurement is 4,994 10,000ths of an inch.
Wow, that's loud. The end! Oh my gosh. Alright, so, alright, did you guys catch that last example? I know that one went a bit fast. He went a bit fast on that last example, but did that last example make sense? At least from where the calculation standpoint was talking about. You guys will have better pictures in the book, that's for sure. Okay. There's some good pictures there in the book, but that's again just talking about the basis of how to find the measurement within a micrometer. Okay, now I'm going to go ahead and go to another video here. All right, since I'm not there. So we're going to go ahead and talk about calipers, the second most major tool to use in a shop. Okay, so how do we measure using calipers here? There are two types of major calipers. There's dial calipers, as you see here. There's a big dial on the calipers, or again, there's also vernier calipers because it has a precise measurement, and then there's the digital calipers that you can also use as well. Surprisingly enough, like digital micrometer, digital calipers are not as accurate as that of the hand-based tool. So the hand-based tool actually is a little bit more, has a little bit less margin of error, which is really good if you're trying to do things with high precision. So, all right, let's take a gander here about how do we use and read a caliper. So let's look at this here. All right.
Welcome to Matt's Metalworking. In this video, I'll be showing you how to use and read a digital caliper. A caliper can take measurements in 4 different ways, using the outside jaws, inside jaws, depth probe, and using the step. A digital caliper is by far the easiest to use and read, can operate in both imperial and metric measurements. However, it is the most expensive to purchase and does require electronic upkeep, being battery replacement. Just like any other precision measuring instrument, this should never be dropped, always kept clean and free of any foreign contaminants, and checked periodically to ensure its accuracy. To go over the parts of the caliper, first is the outside jaws, which is used to measure the outside diameter, length, width, or thickness of an object. Next is the inside jaws, used to measure the inside width of a slot, groove, or hole, or the inside diameter of a bore. The depth probe or rod, used to measure a groove, slot, step, or hole. The beam, or sometimes referred to as the bar, is the frame of the caliper that is stationary and houses the depth probe. A measuring scale used to determine the measurement, in this case only really used as a visual reference, as the digital display provides the full reading. Here is the fine adjustment thumb wheel to achieve accuracy when setting up or adjusting the feel or drag when measuring an object. Then the thumb grip for quick or large adjustments. A thumb screw lock to hold the caliper measurement in place. The digital readout, which shows the current measurement both in imperial and metric readings. The buttons around the display are used to turn the caliper on or off, zero the measurement, and to switch between measuring systems. Battery locations and access door types may vary. Just to give you an idea for this one, the door simply slides open and the battery sits in place.
Okay, so I'm going to stop here for just a second. Basically, the most important parts that he kind of pointed out is what you're using the calipers for. If you're measuring out something here, you want to use the bigger jaws here for outside measurements, the inner jaws for inside measurements, and you also have a depth part here at the very end of the calipers. Now, although this is done with digital reading, as he says, is indeed much easier, but not as precise as what you would have when you have a hand, like a dial calipers. So let's take a look here. I'm actually gonna go to dial calipers here. We actually have some of those in the shop, so I want to show that off because it has mathematical calculations associated with it, and it's pretty straightforward. In all honesty, honestly speaking, you probably, if you're not too worried about precision or whatever, then yeah, use the digital ones. Those are pretty good. You won't really have too much of a trouble. But if you want to go further, then that's fine. You can take the dial calipers
For
here.
gunsmith,
So let's take a look at this dude, and
reloaders, and people that like to work on guns, a dial caliper is an indispensable instrument for making accurate measurements. Your standard dial caliper will let you do an outside diameter like this, let you do an inside diameter like this, or your overall length. Or if you stand this on a hard surface and extend the depth stem, you can make an accurate measurement of the depth of that hole. This particular caliper is an electronic and a direct read caliper. Nice and easy, it's got a 0 button here. You can zero it with a touch of a button. You can also convert it to metric measurements if that helps. The other type of caliper is the old traditional dial caliper, the analog style. This is a little bit more difficult to read. I'll show you how this works. This traditional style caliper has a face like a clock with 100 divisions going all the way around the face. Each one of those divisions is worth 1/1000th of an inch. So if we put it out here, we're at 19 thousandths. Put it over here, 40 thousandths, and so on. Over here on the scale, we've got the numbers 1, 2, 3, 4, and so on. Each one of those stands for 100 thousandths, or 1 revolution of this face. So if I go back to 0, go all the way around once, to the 0 again, I'm at 100 thousandths. That's so you can keep track of where you're at. To measure with this, let's say we have a 6.5 millimeter bullet, which is 264 diameter. So there's 1, 2 on the scale, plus 64 on the face, 264 thousandths. If you pick up your electronic scale or your digital caliper, that's what you get. In addition to doing outside diameters like we just did, you can also do internal diameters with these 2 little prongs up on top. That'll tell you how large the inside of the hole is. In addition, there's a depth gauge on the end here. And what you normally do is pull it out farther than it needs to go, stand it up on the object you want to measure the depth of, and push down the scale till it touches, bring it out, and read it off. This particular piece is 1 inch, 250 thousandths in depth. It takes a little practice to use a dial caliper and get accurate measurements, but don't be discouraged. Even machinists have trouble with it at first. If you have any problems using a tool like this, or you have any questions about how it's done, give us a call on the tech line. We'll be glad to help.
all right. So very, very nice and succinct video. Really like this video. Was really good actually. But you see exactly how things will work out. So with let's say the dial caliper here. Like you said, the dial caliper is kind of an old school one, but some of the ones in the book there do kind of reflect the dial caliper here. So I want to just kind of talk about that there really quick. Some of the ones in the shop there are also have dial calipers. We have a lot of kind of the old school calipers in the shop, and that's only because of the fact that dial calipers are much cheaper than that of digital. Digital's a pretty hefty price tag for one of those, so it's not cheap for the school at least. So hence why I do want to point that out. Now if we go to let's go to some examples here. I think that's fine. Okay, there's a specific example I want to do or look at. There we go. So here we want to look at, we look at this. Here's an example about how to read some calipers, and along the gauge it could have, say, we're going past the 2, that represents 2 inches. Again, for calipers you can have a much longer distance. Each one of these marks is 2/10 of an inch. Okay, so this would be a reference of a vernier calipers. You have that extra last decimal place. And again, we read the vernier scale the same way. So the vernier scale the same way. Thank you. The vernier scale is the same way. Is we see which line lines up the best, and in this case 15 lines up the best. So 1/5 would be your last 2 decimal places there. Multiply that by 0.001, and then so you have 100 thousandths, 25 thousandths, and then 1 thousandths, and then there we go. Thank you, sir. Thank you. appreciate that. You're very kind. So let's take a look at some examples here. All right, let's look at let's look at letter A. So if you look at letter A, all right, how would you read letter A? How would you read letter A? What would that measurement be? Let's take a look at our inches here. We have 2 inches. Okay, so we got 2 inches to start. So let's put it together. Now my handwriting is atrocious, but no, I'm gonna have to work with it. All right. So we have 2. So we have 2 inches. That's the first part here. Notice this line here, the 0 line, goes a little bit past 4, but again doesn't go up to 5. So we're going to have 4 times 0.1 or 100 thousandths. How many places do we go to the right? We go 1, 2, 3. So we go 3 places to the right here of 4. So we're going to take our, go back here. We're going to take our 3, we'll multiply that by 0.025, again 25 thousandths. And then all we have to do here is see which one of these lines line up the best. So we can see here that if we look carefully, the 5 here lines up the best, okay, with the lines up top. So we're going to take that 5 and multiply that by 100 thousandths. So, or by 1/10,000, sorry, or 1,000. So just 1, I guess I'll just say. Okay, so if we do that, we have 2 plus 0.4 plus 0.075 plus 0.005. So we add that together. We get 2.48 inches is how you would read these calipers here. Okay. Now, how about letter B? So can any of you guys tell me what would letter B be in this case? What would letter B be in this case? What do you think? What do you think that one would be? You have 0 here, by the way, so 0 to start. All right. If you're not sure, we can go through this one more time. This will be like one of the examples here. So, all right, so we have 0 to start with. All right. Here we go all the way, there's the 0, so we have up to 7. So we have, again, 7 times 1/10 of an inch. And then we want to take a look here how many places to the right of that 7. So we got 1, 2. Again, the 0 doesn't go past the third one, so we got 2 times 25. Now. And then we see which line best matches up, and we see here it's going to be 11, 12, 10, 11, 12. Looks like what would that be? right? 12, 11, maybe 11, 12, 13, 14, 14. Looks to be 14 out there. So I guess I'm going to choose 14. So we're going to figure this out here. So we get 0.7, so 700. We get 50, and here we get 14. So we get point, hope that's 4, right? Okay. All right, so we get 0.7, 664. Okay, and that'll be our answer for that particular problem. All right. Okay. Any questions about measuring with calipers or micrometers? Not clear about reading the examples in the book? So the examples that you want to kind of go to is there are a couple of examples here that definitely give you a good idea here. Let me reference those pages there. So there are like 2 pages here that help out a lot. This is one of them, 349, but there's another one. Yeah, so the pages I would say look at pages 342 and 343 for the micrometer example. Okay. All right. And for the caliper example here, let's see, where is it here? Yeah, that's going to be, yeah, page 349 here, and just a little bit before that. So bottom of so the bottom of page 348 and page 349 will be those kind of step-by-step things. Again, one thing that you'll need to know, I guess, for the examples when you're reading in the book is just to know what parts of, like, what's the parts of the micrometer there. So if let me go back here to page 342, I'll show you what I'm talking about here. So basically, this part here is the barrel or sleeve. Okay, this is the sleeve here. This is the thimble out here. Okay, so the only 2 things you're looking at is this barrel and this thimble. Okay, so what we're looking at here is, as you see here, when we're presented with a micrometer example, the only 2 things you're going to see is this sleeve and this thimble. Okay, so when we go to the next page and it describes step by step about how to find that, every example is going to reflect with that, will look like this, like you see here at the top of this page. Here's your sleeve and here's your thimble. Okay, and you'll have the numbers there. You follow it step by step, like I did here on the thing, and then you should be able to put that together. The same thing for calipers here as well. So if we go to let's see, where is it here? Yeah, that was on that page. Okay, so go to 348 here as well. And I'm going to look here at this this part here, this kind of bottom part. This talks about, like, if you see here, this is a caliper. This is a vernier caliper specifically. So we have a 0 portion here. This is the vernier scale on the bottom. This is the amount of inches here up top. Each of them represents a tenth. Each mark represents a tenth of an inch. Each little mark here represents a quarter of a tenth of an inch. Okay, so i.e. again 25. So and this is just an inch here too. So as you see here, see how this is kind of broken up here, just like so. And typically for a vernier caliper, it has 15 vernier spaces. Admittingly, a dial caliper is significantly easier, I'm not going to lie, rather than just a picture. So it's not, or again, a digital one by far and away is pretty easy. So that would be, yes, that would be kind of the examples that, yeah, so the micrometer and the micrometer and the caliper, those are probably the two I would put on the test. Probably the two. I don't think I'd put any other measurement ones. I think I probably threw in a couple ones just to kind of highlight them, but I'm not gonna like talk about them at all. So don't expect to see probably a micrometer problem, like how do you read this micrometer, or how do you read this caliper. That kind of problem would definitely appear on the test. So are there any questions about that? Any questions at all? Yeah, look for a little bit more detail, kind of like the little step-by-step instructions there. If you take a look back at my examples through this replay, you'll see exactly how we're going through it one step at a time. Yeah, I know that the examples look a little different. In reality, you're actually doing the same thing. It's just that on the video, it's a little easier when you act. Like, this is kind of like I wish we were face to face, because then I could just hand you a micrometer and then you could work with that. Yeah, the book is just kind of like the more idealized version. So, yeah, I can understand why that can be a little confusing there, Ivan. I'm not gonna lie. You just have to kind of equate what you see in the book to what you would do if you were actually holding the micrometer in your hand. Yeah, I always like practical. Like I said, this is one of those times where I really miss the face-to-face part, because this would be like I could show you a part and then you would measure it. Like what I usually do if we did meet face to face is I'd usually have a box of parts that we have in the lab. I bring a bunch of micrometers for guys to use, and you guys like try it out on your own for like 15-20 minutes, and usually people pick up on it pretty much after that. Like it's not too hard after that. But yeah, I can see why you'd be confused without having to touch the instrument there. So are there any other questions you guys have? Okay. I wish we could meet at school tomorrow. I know. I wish we could. Sadly, I don't think we're going to be allowed to for another semester. I got note from Elgin Community College, and they said, "Nah, we're not doing spring on campus either. So, yep, that went by the wayside. So I wouldn't be surprised if Harper follows suit. Saves my premium gas. Yes, yes, it does. If there's one positive to take out of it, it does save gas money. However, my car kind of sits parked for like 5 out of 7 days of the week. It's sad and lonely and sits there and does nothing. Yes, I do actually. I teach both here at Harper and at ECC. I've been doing that for about 10 years now, actually. I find ECC to be pretty fun, so Harper too. Both places are great. All right. Okay, so what's going to be happening tonight is tonight or maybe early tomorrow. I'll be posting the test here. I'll be posting the practice test to go with that. So I'll be posting both. What's better? They're both equally as good. I'm going to give you an answer down the middle. They both have their both have their good points, and they both have their not so great points. But I think that's fine. No, I don't. I think they both offer. I think they both offer students a chance to get push themselves ahead. I honestly between the two, I don't really prefer one or the other. I like all my students from both places, so um, I don't really have a preference, to be perfectly honest. In 10 years, I get asked that question. I still, after all this time, I still don't have one that I actually lean toward. I like them both equally. Really, in all seriousness, I like them both equally. So that's because I get to goof around regardless at whichever place. So I think that's fine. Let's goof around. Yeah. I get to goof around and teach and have fun, and yeah, I get to do something rewarding. I think that's cool. All right, guys and gals. All right, guys and gals. If there are no more questions, I'm going to head out for the day because I'm going to go ahead and start making up the test here. Yeah, that's what I wanted to do for today. Unless you wanted me to do something else, I can certainly do that. But I wanted to finish off the last two sections there of Chapter 5, and we did talk about the test here at the very beginning. So I figured I'd give you all the information. I heard we were gonna have a pizza party if we all ace the test. Well, I mean we can. That's possible. Maybe we get some like deep dish loos. If you all like super ace the test there. you know, some cheese, extra cheese with the butter crust and a well done kind of shtick. There you go. Birch, there you go. When's the test? The test is due. I'll be posting it tonight or tomorrow. Test is due. Going to be due the 23rd. The homework's due at the same time as well. Towel at 11:59 p.m. Okay. So I meant to put due. Test is due at, yeah. Sono, the first time I heard from you today. Are you doing okay? I saw your name and it's just like, oh, I thought you were dead. That's okay. Oh, yeah, yeah. Still setting up those security cameras to catch that jerk who's trying to break into your car. I swear, you should just leave like a poop package in there for him to take. You know, he opens it up at home, sprays him with poop. You're like, ah, 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 ah. Yeah, that makes sense. Yeah, no, that makes perfect sense. Yeah. If it's a townhome, then yeah, you gotta get permission from the landlord if you rent. Yep. Can't make changes to the exterior without express permission. I live in a condo, so certain things I'm allowed to do. I'm allowed to do a lot of things inside my place, but outside, nah, I don't have a garage, so, but outside, yeah, I have to get like express permission to do certain things. Like I said, Sono, if you don't feel very safe, okay, just again, you do have ways to contact people. All right, I'll be on that list just in case. You can lose me as a resort there, but if you don't feel safe, then at least you have certain safe places to go, family members or myself or anybody else for that matter. So. No problem. You guys look out for me, so I look out for you. That's how it works. Sure, go ahead, Sono. On section 5.4. Okay. What are we converting there on section 5.4? Oh, that's section 5.5. Read the number on the thimble scale opposite the. Read the number on the thimble scale opposite the horizontal line on sleeve. Yeah. So let me go back here. That's actually this last section we just talked about. So what is it talking about when it says that? It's talking about, so it says read the number on the thimble scale opposite the horizontal line on the sleeve. So here would be, say, let's say we're doing this. Here's the horizontal line on the sleeve. The opposite number would be right over here, not going over, not passing. So this would be like 13, right? Because it's 14, 13, yeah. So this would be 13 right here. That would be the number on the opposite there on the sleeve. Here would be the number 4. This would be 4. Here's the horizontal line. And the opposite number here would be 4, or actually, sorry, 6. My apologies. It would be 6. 5, 6. It goes past 6, but it doesn't go past 7. Let's show off another one here. Now that one's a little easy. So, which one would be good? So we're looking at essentially this part right here is the horizontal line, and then you look at this part here at this space. So let's go over the example there in the book. Actually, no, screw that. I'm gonna do this. Let me go. Actually, I'm gonna do that. So I want to do a specific one here. Okay, so gonna be okay. So I'm gonna look at a specific problem here in the book, and we'll talk it over here. So I'm gonna click on this. Okay. Okay, so let's look at this picture here. Here's the picture of the micrometer, okay? Let's go ahead and read this together, okay? So this may help out some of the other guys in the chat too, so hopefully this will be helpful. Okay, so here's our picture of micrometer, and we want to see what this measurement is going to be. Okay, first and foremost, we're going to go in order here. So let's bring out our little paint tool here, and we're going to go in order. We're going to see exactly what we're working with. So let me erase all this junk. Okay. So first part here is we see the 9. Okay, so if we see the 9, we're going to multiply that by 100 thou. Okay. Now, how many lines do you see next to the 9? So take a look carefully there. I know it's a little tough to see, but how many 9s do you see next to the 9? How many lines, I guess? It's hard to say. Yes, good. There are 2 lines next to the 9. I can't even, man. Jeez, that's too much rhyming in my head. All right. So we're going to take 2 times, correct. 2 times 0.025. Okay? It'll be 25 for each one of these next to 9. Okay? Now, this is the horizontal line here on this micrometer. Everybody sees this horizontal line right here, right where my mouse is hovering. We want to take a look at the number on the sleeve here. Okay? So the number on the thimble, pardon me, number on the thimble here, that lines up not the closest, doesn't line up the closest, but it lines up to the number without going past that number. So notice this lines up with 0, but what does that 0 represent specifically? Because this could be technically 5, that could technically be 10, okay? But I want to showcase, even if it's 0 here, what does that represent? That represents 0.001. Okay, so even though there's none of them, this is how I do the calculation here for something like this. That last step is if we have a vernier caliper, if they had the extra, extra lines, then we would go one step further. But they're not, so we're just going to deal with this. So we deal with, we got 0.90, 0.050, and 0. So the answer for this one is 0.950. Okay, so let's enter this in. Okay, let's check that. Oh, I thought I erased this. Sorry. Oh, we get that wrong there. Unless that represents 9 inches, in which case that'd be 9.5 inches, but no, that's definitely right. Let's see here. Okay, let me take a look here. I just want to check to see what they're looking at. Yeah, that part's easy. Okay, right. Okay, that's what we got here. 0.950 inches. There are 3 lines for the second one? Really? Oh, did I miss one? I might have missed one. Actually, I need to, you know what? I need to make that bigger. Maybe I can't read that. 1, 2. Oh, there are 3. Oh, okay. Yeah, so it's 0.75. Yeah. All right, that was my fault. I couldn't see the third line there, but it's just a brush right there. All right. That's my fault because I couldn't see that third line there. All right, my bad on that. My bad. Okay, that's actually pretty tough for me because usually I can see the lines. This is why, like, this is like if you have the actual tool, it's like super helpful. But like I said, a picture doesn't really reflect real life all the time. Yeah, I understand that. That's fair. That's fair. So we're going to make the assumption that this third one here is right here. It's just not completely visible. So because of the drawing, this extra line is right here. So this would be 0.6 and then 0.075 and then 0 for that. So it would be 0.675 for this. Yeah, that I can totally get. So try that. Okay. Right. So let's at least excuse me. Let's go ahead and make this. I'll make this concession here. Yeah, there is an extra line here. It's just not. You just can't see it based on the picture. But yeah, it's 0.75. There's 3 lines here. It would be actually under, right a touch right underneath the thimble here. So yeah, that is an issue there. I guess I can totally see where that can be an issue. So that's very, very true. No, I'm glad you brought that to my attention because I wasn't aware that that was a thing until now. So that one's actually really straightforward. But so then this one here would be type this in, right? Yeah. All right. So all right, let's type this out here. So all right, let me write that. Let me acknowledge that. That's a good point there. I hadn't realized it was actually that finicky. So yeah, that's for those type of problems there. So I'm gonna want to look actually. I want to check one thing here actually in relation to that question. I want to check this next page if they have it. They do. Okay. So I'm going to check. Let's check these, okay, and see if there's any exceptions to these as well. There's also micrometer ones. So let's talk about millimeters as opposed to that. So this is 30, 31, 32, 33, 34, 35, 36, 37. This is 37, and I think that's 0.24. No, here. Oh, right, that has to be done with 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No, that's 7. All right, so we got 30. I got 7. That's 7 times 0.5, and that's 0.1. Okay, got it. So let's do that out real fast. I know I didn't go over the millimeters one. I'm not going to give you a millimeters one, by the way. So, but I just want to. Yeah, it's 30 plus 7 times 0.5 plus 24 times 0.01. So this is let's go 33.74. Okay, good. That's for metric micrometers, so how that works. Okay, I'm not gonna do the metric one, but the inch one, yeah, the inch one would be one that I would put on. Okay, I just wanted to make sure that it didn't. So it does it for the inch micrometers, but not the metric ones. That's really interesting. It's pretty weird, but yeah. All right. I guess I learned something today about that. So. I hope that clears up that confusion there, and I do apologize about that, Sono, and everybody else for that matter. For B6, would it be 16? Yes, 16 times 0.001. That's correct. That's right. Yes, you are correct. The second number, yeah, here you get point. You'd have 0.05. So it'd be point. First number 6. It would be point. Be 4 plus 0.05 plus 16. Yeah, so no, but does it make more sense now? Now that we did a couple of examples there. No, I would understand you had a mini mental breakdown because it had that missing piece that it kind of assumed you knew, but you didn't. So that's okay. Now that we know it includes like a hidden line in there, then hopefully that'll make it easier. I didn't realize the book did that, so again, I'm sorry about that. That's pretty close. That's pretty sneaky. So no problem. You got to say it the right way. You did it. You did it opposite. It's domo arigato. And then if you want to say you're welcome, you say do itashimashite. Do itashimashite means you're welcome. I can't play CSGO right now. I got a test to make, you know? I'd love to later, though. But I gotta make this test first, and then maybe if I'm not too tired. Yeah, well, we gotta make the test for you, you know? It's kind of a thing. uh, I gotta do that responsible thing, you know. All right. Okay. Yeah. You wish you're on the corner of you wish and not happening. uh, worth the try. Wah, wah. All right. Okay, everybody. We will see you all later. All right. Everyone, I'm going to go make the test. Thank you. Thank you very much, Sono. Have a wonderful night yourself. Get those security cameras up so you can finally catch that dude or dudette who's breaking in your car. Ivan, thank you very much. You have a wonderful night yourself. Gustavo, have a great night, okay? Luna, have a great night. Everyone have a wonderful night, and I will see you all next week. But be on the lookout for the test either today or tomorrow. It will be posted, and again, will be due next week at 11:59. All right, 23rd. All right, have a great night, everybody, and we will see you all later. All right, bye.